Hello, everyone. So here, chapter 2, right? Types of compounds. So ionic compounds are usually formed when ionic bonding occurs with oppositively charged ions. So in chemical reactions, atoms can lose or gain electrons, right? To form particles called ions. And there are two kinds of ions. The cation ions that are positive and anions that are negative. So the cation ions, these are atoms that lose electrons, and anions, they have negative charge. So these are the anions are atoms that gained extra electrons, right? So here, are you seeing this table? These ones here, they can get like positive, and in the ending, you have the ones that can become negative. So, for example, sodium chloride, right? Sodium chloride. The sodium is atomic number 11, so 11 protons, 11 electrons. The sodium atom, 11 protons, 11 electrons. But when sodium is bonded to chlorine, sodium will donate one electron to chlorine. So that means sodium lost one electron. When sodium atom loses one electron, the sodium atom now will be a sodium plus ion with 11 protons because the number of protons does not change, but electrons, yes. So before the sodium atom had 11 electrons, now 10 electrons. So because the sodium atom is losing electrons, so sodium ion is a cation, becomes positive, sodium plus. Because lost plus one because lost one electron. Right? Then chlorine. The atomic number for chlorine is 17. So 17 protons, 17 electrons, right? So when the chlorine gains one electron from sodium here, the chlorine is gaining here one extra electrons. One extra electron. So initially 17 protons, 17 protons. Please remember the protons numbers. The proton numbers do not change, right? And initially 17 electrons now gained one electron. So now chloride ion now is ion because it has a charge. Now has 18 electrons. So chlorine 17 electrons, the chloride ion 18 electrons. And the chloride ion is an anion because it has negative charge. So when change from atom to ions is because lost or gain electron. So sodium atom 11 electrons, sodium atom 11 electrons, sodium ion 10 electrons, chlorine atom 17 electrons, chloride ion 18 electrons, right? Okay. So in binary compounds, the electrons are transferred from the metal to the non-metal. So here, the sodium is a metal, and the chlorine is non-metal, right? So the positive cations, so the metals group 1, 1A, 2A, group 3A, right? They're metals, they'll become positive, like here, right? 1A, 2A, 3A. So they become positive because they lose electrons. So the atoms, they are gaining or losing electrons to achieve the same valence of electron as the nearest noble gas. Noble gases usually have 8 valence electrons. The last table, the last column here is the noble gases. So the atoms, they are losing or gaining electrons to achieve the same noble gas valence electrons number. So here, fluorine had initially 9 electrons. When the fluorine gets 1 electron, becomes fluoride ion, so change from 9 electrons to 10 electrons. And which noble gas here has 10 electrons? It is neon. Neon. Right? Okay, so in a chemical formula for ionic compound, the symbols and subscripts are written in the lowest whole number ratio of the atoms per ion of ionic compounds. The sum of ion charge equals 0. That means the positive charge is equal to total negative charge. So sodium, right, loses 1 electron, so plus 1. Here 1 plus. And chlorine gain 1 electron, so 1 minus. I've seen here plus 1 from sodium, and minus 1 for chlorine. Now the net charge is 0, right? Okay. Right. So now writing chemical names from chemical formulas. When name ionic compound, they write the compounds that have metal and non-metal. They are ionic compounds. And the metals are positive, and the metals, no metals negative. So when naming an ionic compound, the name of the metal is written first and is the same as the name of the element. So here, right? In HCl, you know that sodium is still the same name, right? But the name of the nonmetal is the first syllable of the nonmetal name plus I the ending and is written second. So sodium chloride, right? But Cl is chlorine and it's changed the last syllable to ide. A space is placed between the names of the metal and the non-metal ion. So here, K2O. So what K, you know that's potassium, right? And oxygen will become oxide. So K2O is potassium oxide. Oxide, all right? So here, CaO. The name of the metal does not change. So calcium is still calcium, right? And the oxygen will be coming out oxide. So CaO will be calcium oxide. All right. Okay. So write chemical formulas from chemical names, right? So here, they have here the steps. The formula of ionic compound is written from, so the first part of the name that describes the metal ion, you saw that, right? Previous example here. The first part of the name is the metal ion. And the second part is the non-metal, right? Okay, so step 1. Write chemical formulas from chemical names. Step 1, write the symbol of the metal and its charge. So, for example, here, magnesium is the group 2A, so magnesium here, 2 plus, so magnesium 2 plus. Then write the symbol for the non-metal and its charge. So nitrogen here, right? I've seen the charge for nitrogen is a Na3 minus, so Na3 minus. Then step 3, make the magnitude of the charge of each ion without the sign. So make the magnitude of the charge of each ion the subscript for the other ion. For example, here, magnesium is a 2 plus, nitrogen is a 3 plus. We need to make sure, right, the net charge is 0. What that means here. So when you have different charge like this here, to make sure the total on a net charge is 0, I will see the charge of the 2 plus will indicate how many nitrogens we need. In the charge for the nitrogen will indicate how many magnesiums we need. So magnesium, we have 3 magnesiums and 2 nitrogens. So magnesium here, nitride, right? So let's check if the math is really 0 here, the net charge. 2 plus times 3, right? Plus 6. 2 times minus 3 minus 6. So I will see here, the net charge is 0. Right? Why sodium chloride here do not need to put numbers here? So the charge for sodium is 1 plus, right? But the chlorine is 1 minus, so plus 1 minus 1 is 0. So here, everything already was net charge 0, right? Same thing for calcium oxide. Do not have numbers here because the charge for calcium is 2 plus, and the charge for oxygen is a 2 minus. So the net charge will be 0 already. Okay, so see this one ionic compounds, we just had to write the name by adding "ide" in this non-metal, right? The first one, write as it is. The second one, change the last syllable to "ide." Like here, lead, sulfide. But I think that the lead here has 1 minus for the resolution. I think it's a little better. So what are the numbers inside here? So the transition metals, they are ionic compounds that contain a metal that can form more than one type of cations. So the main difference is the ability to form more than one type of charge. So for example, iron can be sometimes iron 2 plus or iron 3 plus. So how we're gonna name the compounds, the transition metals? The transition metals, I'm seeing here the middle here. The transition metals here, they have the charge can change. That's why for transition metal, we need to say the charge in the name. So we'll be write the numbers, algorithm numbers on the side of the metal here. For example, I'm seeing here iron 2 plus will be iron 2, and iron 3 plus will be iron 3. In Roman numbers, see here. 1, right? 2, 3, and 4. Roman numbers. Okay, so let's see this one. Iron and oxygen, only this way here. Okay, so iron, the oxygen is a 2 minus. What's going to be the charge for this iron here? So I've seen there is no numbers, the subscript here, no numbers. So in that case, here iron is a 2 plus. Because if you do, okay, 2 plus and 2 minus, then charge is 0, right? Okay. So what's the name for this one? Iron, right? Start as the first one. Iron. What's the charge? 2 plus. So 2 and the metal name, oxide. Should be more closer here. So iron 2 oxide. In about when 53 here. So okay, so what should they charge you for this ones, right? You know, right? The iron 203. The number 2 here for the iron indicates the charge for the oxygen, and the number of oxygen 3 indicates the charge for the iron, right? The same idea here. The charge of the metal here becomes the number for the non-metal. And the same thing here. When they are different charges like this. Okay, what's the name for this one? Right, for iron. So it will be iron. What's the charge here? 3 plus, so iron 3 oxide. Right? So this way we have transition metals. We need to write the charge as Roman numbers. All right. Okay, so let's say this one. Copper 2 chloride. Okay, so let's see copper, right? Cu. And chloride is a Cl, right? So let's see, set the copper to chloride, the charge for copper is 2. So each chlorine, all the gases here, the atoms in group 7A, right, is a -1. So how many chlorines do we need to make the net charge 0? 2 plus, the everything here, the 2 plus from copper will indicate how many chlorines we have. And -1 of chlorine is how many copper we need here. Just 1 copper and 2 chlorine. So let's check if the net charge is really 0 here. 2 plus 1 copper, 1 times 2. Plus 2, 2 times -1 minus 2. So yes, the net charge here is 0. Right? Okay. Dynamic compounds. is when you have polyatomic ions. So polyatomic ions are a group of atoms that act as a unit and carry the overall charge. So the polyatomic ions, for example, here, nitrate has 1 nitrogen and 3 oxygen. Nitrite, 1 nitrogen and 2 oxygen. So the ternary compounds, right, the ones that have polyatomic ions, because you have at least 3 different atoms. We have nanometals such as phosphorus, sulfur, carbon, or nitrogen. They are covalent bonded to oxygen atoms, usually have one minus, 2 minus, 3 minus, and even 1 plus charge. For example, here, aluminum hydroxide, AlO3, OH3. So the seeing OH is in parentheses here, because this is a polyatomic ion that you have 3 polyatomic ion, 3 oxides. So aluminum hydroxide here, the 3 means that you have 3 OH, so 3 hydroxides. So many products contain polyatomic ions, which are groups of ions that have an ionic charge. All right, okay. So I've seen here this polyatomic ion table. Nitrate, NO3 minus. Nitrate, 3 oxygens. When the polyatomic ion loses 1 oxygen, you change from 8 to 8. So nitrate, nitrite, right? For example, here, let's see here. SO4 2 minus. The SO4 2 minus is sulfate. Now the SO4 is becoming now SO3 lost to 1 oxygen, right? So 1 oxygen less. So instead to be sulfate, now it will be sulfite. So every time I'm going to have polyatomic ion, the name here, phosphate. All phosphate will be PO4 3 minus. Now, if phosphate has 4 oxygen, so what's the name when you have PO3? We change from 8 to 8. So nitrate, 3 oxygens, nitrite, 2 oxygens. So we need to learn the name of the eights. If you know the eights, like nitrate, sulfate, phosphate, chlorate, if you learn the eights, you know what will be the formula for the eights. How do you know? Because if you learn the eights, for example here, chlorate is ClO3 minus. So chlorate has 3 oxygens. When you change it from chlorate to chloride means you have now 1 oxygen less. So chloride has 2 oxygens, right? But if you have another oxygen removed, so here, initially was CO3 minus, ClO3 minus chlorate, ClO2 minus chloride. Now, if you have 2 oxygen less from the original, you change it from chlorate to 2 oxygens chloride, and if it is 1 oxygen, it will be hypochlorite. So here, minus 1 oxygen will be chloride. If it is minus 2 oxygens, will be hypochlorite. Right? But if you add more oxygen, so chlorate is a ClO3, 3 oxygens, right? If it's gain one extra oxygen, we added the pair before. If you add one extra oxygen, we change for chlorate to perchlorate, right? So nitrate, NO3 minus. Sulfate, SO4 2 minus. Phosphate, PO4 3 minus. Chlorate, ClO3 minus. And the hydroxide, you need to memorize hydroxide. Also, hydroxide is OH minus. It's called hydroxide. Okay. Oh, actually, usually the polyatomic ions, they are negative. I've seen here, usually. But then the ammonium is the positive. NH4 plus. Right. Okay, so let's check it, right? Writing formulas for compounds containing a polyatomic ion. So when writing formulas for ionic compounds containing polyatomic ions, we use the same rules for charge balance as those for simple ionic compounds. So let's see this example here. Magnesium nitrate. So nitrate, I've seen here, the nitrate has charge 1 minus, right? Here. So the nitrate is here, -1. Magnesium, magnesium group 2A, correct? Magnesium 2A, so a 2 plus. So you know magnesium is a 2 plus. So you know the net charge needs to be the same, right? So how many nitrates do you need here? Magnesium, each magnesium is a 2 plus. Each nitrate is 1 minus right here. So you needed to make this portion here 2 minus, meaning you needed 2 nitrates. So the formula for magnesium nitrate is magnesium, parenthesis, NO3, 2 indicates that you need 2 nitrates. So parentheses are placed around polyatomic ion. So the subscript is placed just outside the parentheses. Okay, so let's practice this one, right? Calcium nitrate. So calcium, group 2A. So calcium nodes are 2 plus, right? Nitrate, you already know that nitrate, right? The charge for the nitrate is 1 minus, right? So how many nitrates do you need to cancel out the 2 plus? You need 2 nitrates. So sorry, it was red here. Calcium nitrate. 2 plus for calcium, needed 2 nitrates here. All right, so name compounds with polyatomic ion. So when name ionic compounds containing polyatomic ions, first write the positive ion, like here, calcium, right? And then the second, write the name of the polyatomic ion. So we need to recognize the polyatomic ions in chemical formula to help to be able to name the compound correctly. So the ionic compounds, we do not need prefixes. So the ionic compounds, you don't add like choose sulfate, you don't add choose the di, tri, you don't add prefix. From here is sodium sulfate. Do not say there's disodium sulfate because they are ionic compounds, right? So you have the metal portion that's positive, and then the non-metal. So the ionic compounds, you do not say the prefixes. So sodium sulfate, iron 3 phosphate, aluminum carbonate. Oops. So now the next portion is for molecular covalent compounds. So molecular compounds are composed of molecules and almost contain only nonmetals or metalloids. So molecular compounds, or also called covalent compounds, these compounds do not involve ions or charge. So in the ionic compounds, we also had a positive and a negative, right? For the ionic compounds, they were transferring electrons. But for covalent, they are sharing electrons. This is why covalent compounds, they do not have ions or charge. These 7 elements here, they occur naturally as molecules containing 2 atoms, so hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine here. Write chemical names and chemical formulas for covalent compounds. So, it's actually covalent compounds is simpler than performing the naming ionic compounds, mainly because for covalent compounds, we do not have charges, right? So what you change for covalent compounds? The first nonmetal by its element name, like here, nitrogen. In the second nonmetal, it's named by use the first syllable and its name followed by I. And for covalent compounds, we add subscripts indicating the number of atoms. For example, here, NO2. So nitrogen, right? Nitrogen. How many oxygens you have here? 2 oxygens, so nitrogen dioxide, right? The next one, N2O3. How many nitrogens here? 2 nitrogens, so dinitrogen. How many oxygens? 3. What's the prefix for 3? Tri, so dinitrogen trioxide. All right. Okay, we all know that H2O is water, right? Called water. But what's the name here following the rule here? How many hydrogens you have? So dihydrogen. How many oxygens you have here? 1, so monoxide, hydrogen monoxide. I've seen that you only write mono for the second element, like here. Nitrogen dioxide, do not say mono nitrogen, because when the first one has only 1, we do not say mono. You only say mono when the second has 1, not the first. For example, right? Carbon dioxide, carbon monoxide. I only say monoxide for the second one, right? Carbon dioxide, carbon monoxide. And about this one, P2O5. What the prefix for 2 would be di, right? So diphosphorus. And for was the prefix for 5? Penta, right? So diphosphorus pentaoxide. All right. Okay. Okay, so now chemical formulas. Oh, so writing chemical names and chemical formulas for acids. In the anion, so if the anion in the acid ends in "ide", I'm going to change the end of the acid to "ic acid and add the prefix hydro, right? So here, right? The metal for HCl, the name for Cl, right? The anion Cl is chloride. So when it is "ide", change "ide" to "ic acid and add the prefix, I'm sorry. Oh, yes, okay, hydro. So HCl, hydrochloric acid. Br like bromine, the ion is called bromide. The anion is bromide. So I'm going to change the bromide to ic acid, right? And add hydro before, so hydrobromic acid. All right. If the anion in the acid ends in "ate", like nitrate, chlorate, right? We change the "ate" to ending "ic acid, right? So what you saw in the polyatomic table, polyatomic ion table, right? The chlorate is Cl3 minus, right? So here. So Cl3 minus, the 8 change the end to "ic acid. So chlorate will be in the acid with hydrogen before you be chloric acid. And here Cl4 minus is a perchlorate, so we are going to be perchloric acid, right? We are adding "ic acid. And here we also add "ic acid here. The difference is that when it's just the ions, we add hydro, hydro, hydro. And if it is the anion finishing in 8, you'll be adding "ic acid. So finishing "ide", you add "ic acid" and hydro before. If it is finishing 8, only change the ending to "ic acid. Right. Then, if the anion in the end ends in "ite", like here, right? Chlorate, Cl3 minus, chloride, Cl2 minus. So chloride, if the anion ends in in "ite", change the end to O's acid. So Cl O2 minus is a chloride, right? When it becomes an acid, additionally, all acids will have hydrogen. This acid you have hydrogen before. So chlorose acid, right? And this one, hypochlorite, right? With ClO minus, hypochlorite will be hypochlorous acid. And the chloride will be chlorous acid. For example, H2CO4 and H2SO3. So SO4. What was SO4 name, right? So here, sulfate. If it is a sulfate, how are we gonna name this one? So ending in 8, we change it to "ic acid. Right, so it's gonna be the C H2SO4 will be sulfuric acid, right? All right. sulfuric acid for H2SO4, and for H2SO3 will be sulfurous acid. So here you change it to ic acid, and in inic acid, right? And here to, finishing in sulfurous acid. Ose acid, right? Okay. Now, the last portion, chapter 2, is about organic compound nomenclature. This portion is very, very basic portion of nomenclature of organic compounds. So, organic compounds, they are organic chemistry is a study of carbon. Organic chemistry has its own nomenclature system. And if they are only for the simplest hydrocarbons, because they have only hydrogen and carbon. So there are different groups of organic compounds. The basic one is hydrocarbons, but you have alcohols, aldehydes, so different ones. The most simple one is hydrocarbons. The simplest hydrocarbons compounds contain only carbon and hydrogen, and all the bonds for the alkanes, all bonds are single bonds. So I think just one line, CH, CH, CH. H means single bonds individually each one. So the first part of the name is related to the number of carbons. So if you have only one carbon, math here. One carbon. And the ending depends on the group of the type of organic compound you have here. In the case, alkanes, all alkanes, the last syllable is ane. Alkanes, they are all hydrocarbons with single bonds, all single bonds. So the first portion is about how many carbons we have. So meth, one carbon, F, two carbons, Pro, three carbons, and bute, four carbons. It's like this. One. Oopsie. Oh man. Three. Drop. Four is bute. And after 4, 5, 6, 7, 8 is the normal prefix way that you already know, like the Greek one. So 5, penta, right? 6, hexa, and continuing. But from 1 to 4, a special nomenclature for organic chemistry. 1 carbon is start with meth, 2 carbons, F, 3 carbons, prop, 4 carbons, bute. But after 5, so 5 and next one is like 5 penta, 6 hexa is the normal way of say the numbers of the atoms. So all alkanes, they are hydrocarbons with single bonds, right? So finish with ane. So here, CH4 is only one carbon, so meth, and only carbon and hydrogen with single bonds, so finish in ane. So CH4, the name is methane. And about this one, how many carbons we have here? 1, 2 carbons, right? So the prefix would be eth, ethane. Finish with ane because it's only carbon and hydrogen with single bonds. So methane, ethane, propane, Probably because you have 3 carbons, right? And feeling of N because it's only CH and single bonds, propane. Right, so another group, organic chemistry group, is alcohols. When a hydrogen in alkane is replaced with something else, like here, OH, the name will change and also change the group. For example, as seen here, the hydrogen now was replaced to a OH, changed from methane to methanol, because now when a hydrogen in alkane replaced with a functional group like OH, in that case here, change from hydrocarbon to alcohols. All alcohols, the last syllable here will be finishing in all. But before was finishing in ending. So when you see the OH, like this here, replace the hydrogen by OH, we change from hydrocarbons to alcohols. So methane with OH will be methanol, ethane with OH will be ethanol, and propane now with OH here will be propanol. One propanol because one is saying the carbon is on the first, the OH is in the first carbon here. This one. So when 2 or more molecules have the same formula but different compounds, they are called isomers. For example, 1 propanol and 2 propanol. So let's write this one here. C propanol, prop, how many carbons? 3. Okay, 1, 2, 3. So let's connect the carbon with carbon. Each carbon needs to make 4 bonds. So let's fill out with hydrogens, right? But first, let's add the OH. This one says 1 propanol. That means we have 1 OH in carbon 1. The carbon 1 can be from left to right or from right to left. Like you can write like here, OH. So after you add the functional group here in OH, you are going to add hydrogens to make sure all carbons have 4 bonds. So here, this carbon, how many bonds is making? 2 bonds. So let's add 2 hydrogens. The second carbon here, only 2 bonds. So let's add 2 more hydrogens. And carbon here is this one has only 1 bond. So we need to add 3 hydrogens. So this is 1 propanol, right? Now let's do this one. 2 propanol here. So propanol, right? Propanol, so 3 carbons anyway, still. The OH is on the number carbon 2. So this carbon, if it's from left to right, or right to left, is still this carbon from the center is still the second carbon, right? Now we are going to add hydrogen to make sure all the carbons make 4 bonds, right? So here, carbons, 1, 2, 1, 2, 3, 4 bonds, okay. This carbon here in the middle is making already 1, 2, 3 bonds, right? So how many hydrogens needed here? Needs 1 bond with hydrogen to make 4 bonds. In the last carbon here is make only 1 bonding, so need to add 3 hydrogens. So let me add here is the So you guys can remember home. What do the honks mean here? Means hydrogen, 1 bond, oxygen, 2 bonds, nitrogen, 3 bonds, and carbon is make 4 bonds. Honk is just a tip for to memorize the numbers of bonds each compound in each of these compounds will be making to be stable. Okay, so now when the compounds they have the same chemical formula, they are called isomers here. Let's check. Let's check if that's true, right? How many carbons here? 3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So 8 hydrogens here. How many oxygens? Only 1. So the chemical formula for 1-propanol is C3H8O, right? And about the 2-propanol here. How many carbons? 1, 2, 3. Guys, this is just one line because I did not write correctly first. So C3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And only 1 oxygen. So the same formulas, but different compounds. I mean, they are isomers. Isomers. Okay, guys. So this is the end of chapter 2. Yes, right?